Hi, welcome back to General Mathematics class.
So as requested, I will be providing you with a video instruction on how to graph rational functions. So I will be giving you three examples of rational functions, and this will be distributed into three separate videos. So our first example is f of x is equal to 3x over x plus 3. The first step is factor out the numerator and the denominator. Since both numerator and denominator are already on linear form, what we will do is just simply proceed with our second step, which is to look for or determine the x and y intercepts. So in order to solve for the x-intercept, we make f of x or the y equal to 0. That would be 0 is equal to 3x all over x plus 3. Solving for the value of x, we will multiply x plus 3 on both sides of the equation. Dividing out, you will have what remains with us is 0 is equal to 3x. Then to isolate x, you will divide both sides of the equation by 3. They cancel out. X is equal to 0. So if x is equal to 0 while y is equal to 0, the x-intercept is actually 0, 0, which is on the origin. For the y-intercept, we do the same process. We make all x's 0. So we have y is equal to 3 times 0 all over 0 plus 3. That's equal to 0 over 3, which is also equal to 0 again. Y-intercept is 0, 0. So that means that both the x and y-intercept are found on the origin. Next is we solve for the vertical asymptote. In order to solve for the vertical asymptote, we will equate the denominator to 0. And since we did not reduce the rational function in lowest term, we'll just use the original denominator. So that's x plus 3 equals 0. Solving for x, we have x is equal to negative 3. This means that the vertical asymptote is in x is equal to negative 3. Next, we proceed to determining the horizontal asymptote. For the horizontal asymptote, we will just compare the degree of numerator and the degree of the denominator. If you notice, both are in the linear form, so both degrees of the numerator and the denominator are 1. And since we have equal degrees for both numerator and denominator, y is equal to the numerical coefficient of the one having the x variable. That means 3 over 1 or simply 3. So for our horizontal asymptote, that is y is equal to positive 3. And of course, our oblique asymptote automatically does not exist. Now we proceed to graphing. Since we don't have any more fractions, we can just simply opt interval of our choice. So we can choose 2 or 3 or 4. So let's just have by 2s. So that's 1, 2, 3, 4, 5, then 1, 2, 3, 4, 1, 2, 3, 4, 5. We have 1, 2, 3, 4. So we proceed with graphing our intercepts. Again, both x and y intercepts are found in the origin. This means that we have a single point over there. And let's proceed with our vertical asymptote. X is equal to negative 3. So this is our x-axis. The negative 3 is over here. Then we make an imaginary line represented by the broken lines. Then for our horizontal asymptote, y is equal to positive 3. That's 1, 2, 3. Again, horizontal asymptote is a broken line. Upon moving to the left, it should be noted that we must not cross y is equal to 3 as our asymptote. It means that the movement of our graph is downwards. So be downwards. And then we proceed with to the right direction. And the asymptote that we must go nearer to is above the origin. So that goes the direction of our graph. Then we proceed with graphing or plotting points to the left of our vertical asymptote, and the nearest whole number to the left is negative 4. This means that we have to use x is equal to negative 4 to substitute 4x on our rational function. We have y is equal to 3 times negative 4 all over negative 4 plus 3, giving us negative 12 over negative 1, or this is also equal to positive 12. So obviously positive 12 is above our horizontal asymptote. This means that if this is 4 coming from above, so that is how the graph of f of x is equal to 3x over x plus 3 would look like. So that would be it. The second rational function will be discussed in the next video.